Thanks a lot, Allert, for a crystal clear talk, I would say.
Hopefully.
It seems that all knots are untied now. But who knows, the audience might have some knots that are still tied, so go ahead. Yeah.
There seems to be a discrepancy between the depletion of the cockle density, for example, as you showed, and the optimal cockle density of a factor of 10.
Where they started foraging, you mean,
Yes.
initially?
Yeah.
Yeah.
Why is that?
But this is a different year, so with different average densities also. And yeah, so this, the first plots were 100 by 100 meters were in 2010, and this large scale was in 2011. So there's different years with different averages and different choices that the knots have to make. And yeah, and what I showed at the end, it's also a subset of 18 individuals that selected these places, but it doesn't mean that they weren't seen elsewhere also. But I didn't repeat the question. So I should remind you.
Remember.
Yeah, that was it. Yeah.
Well, a new chance to repeat the question of Thomas.
Well, yeah, going on about it, then still, to me it seems difficult to explain why red knots would deplete cockle densities down to 100 individuals per square meter, while at another plot, let's see, there are still densities of 50 of all kinds.
Yeah, so the question is, the question is why knots would deplete certain patches down to 50 knot cockles per square meter, whereas at other patches there's still very large densities available to them. Well, that has to do also, I think, because of density dependence. That at these very large densities, the qualities are also lower of these cockles. So it's a trade-off between quantity and quality. And I didn't show this here, but it's also individual specific. So depending on the gizzard size of these individuals, they have different locations, different points in this trade-off where they maximize their intake rate.
Did you finally answer the question, your last question you asked yourself?
Yeah, I think so, but maybe I didn't iterate that enough.
It was, can you predict the distribution of the birds? And you know the distribution of the prey?
Yeah. So the question is, did I answer?
No.
Sorry?
My answer no.
Well, my answer is yes. So the question was, can we predict, so my fourth question, can we predict the spatial distribution of predators based on the spatial distribution of their prey? And Bert's answer is no, but my answer is yes. So I haven't been clear enough about that. So if you know the cockle densities, so the spatial distribution of the densities, as well as their qualities, then you can estimate where these red knots will forage.
My idea was that the knots go to the right places, where you can optimize their food intake. But there are many places where they don't go. Although there is enough food at the right quality, matching their preference.
Yeah.
So they go to the right places, but there are also a lot of places where they don't go.
Yeah. Yeah, but
So
these, as I said, there's also
the
a
reason that I said, well, the answer actually is no.
So the remark is, they did go to places where they maximize their energy intake rate, but there's also a lot of places where they could maximize their energy intake rate, but they don't go there.
Yeah.
Well, as I said, we have a group of 18 individuals, and it doesn't mean that knots were only seen foraging here. There's also other places of birds that we didn't tag, that went elsewhere, for instance. That's one of the reasons that they, and that can also have to do with social attraction, that they, if one goes there, so there's all kinds of reasons that, that you don't have to find them everywhere, if that habitat is suitable. That's what carrying capacity is.
Geert.
Yeah, so I think you had a very convincing story to say that you know the prey density and quality that you can predict where knots are. And you said that this has like also applied relevance. But I guess the challenge is now, let's say you would like to know at any point in time, for example, what are the places, for example, to protect. I think you have a challenge because it's so dynamic that even if you have a simple sampling, which is one time instance, ideally you would have the same sampling scheme but then every week or every 2 weeks. So how would you solve this more practical question?
Yeah, that's a difficult question. So the question is how to extend this to a more applied area and throughout the year, how you would do that. predict where these birds are. You cannot sample the whole year round in a style of CBUS, so hopefully there's some kind of correlation between the average in one period of time and other times of the year. And if you can highlight these areas, the most used areas, as I showed here, if you could protect that, for instance, that would give you protection the whole year round. Hopefully, that would be one thing. Yeah. But also, what another difficulty is, it's not only the dynamics of prey availability and prey quality and densities, which changes throughout the year, but it's also state dependent. It's so that where these knots maximize their interprey is also dependent on themselves, so on their gizzard mass. So that makes it more complex as well.
So may I respond quickly? So for example, what I think might be very fruitful to look at is actually abiotic conditions, because they tend to be more fixed in terms of prey. So I mean, you're showing that actually plants have changed a lot, but perhaps actually the sediment type and that may actually be a very good predictor of where the good sites are.
Especially for cockle, so there could be abiotic factors that predict these densities very well. So you don't have to measure densities, but you can measure abiotic factors that are less variable. And yeah, I agree. And around Giet you also saw this ring of cockle densities. So that could be related to, for instance, mudflat height, or the depth of the water, a certain water level. So that could be an abiotic factor that is on. But then it's about density only. It's also about density dependence. The biotic of the cockles themselves.
Okay, yeah, has a question.
You did the sampling of the cockles before you had the recordings of the knots, right?
Yeah.
So how do you know when you did the recordings that they haven't been, before you started the recordings, at the richest spots?
Yeah.
Maybe they've been there before you started the recordings, have depleted them already, and then went to 2000s.
So yeah. So how do I know, the question is, how do I know that before we started recording that they didn't deplete the richest patch already? And now, if I understand correctly, they're in the process of depleting that patch, which has intermediate densities now, and then they will switch, as a flock, they will switch to other high densities. Yeah, that could be the case. But also what you see, if you look at knots, they don't consistently go to the same patch over and over, and they don't stay there for the whole low tide period. They go from patch to patch, and they have different patch visits. So it's not that they deplete one place completely before switching to the next.
No, but when were the recordings?
August, half August.
Yeah, so maybe in the beginning of August, they already depleted the richest patches. And then they know that, still know that, there's no reason to
Sorry, yeah, no, I understand. So this patch doesn't exist anymore.
Yeah.
Now, that's not, no, we resampled these densities. I misunderstood your question. So the question that is, this high density patch of 5,000 cockles per square meter doesn't exist anymore at the time we recorded the behavior of red knots, because they depleted this already. But this is not the case, because we resampled cockle densities like a month later again. And the pattern was more or less the difference in density between the first and the final sampling was consistent with the locations where we saw the red knots foraging with the tracking data.
Okay, Thomas, and then we go to Zeeland.
Yeah, kind of a follow-up to this question. If you think about it, you maybe not always know if there has been predation or not. I find it actually curious that you find such a clear relationship between cockle densities and their quality, because you could you would think that if a patch has been predated, then the density has become much lower. A priori, you would say that a low density would have high quality cockles, but if it was a high quality patch and knots had been there, and you also found in some other research of yours that they actually select for the good quality cockles, so you would actually expect very low quality cockles at the low density sites if they have been predated.
Yeah, this is also a matter of how fast they recuperate the remaining cockles, I think, so that they're released from density dependence. But it's an interesting thought. Yeah.
Is there any knowledge about how fast they can grow flesh moths?
Yeah, there must be. Jan Drent probably knows this. Nee, ask Anouk. She is
Oh, Anouk. Yeah.
He is asked.
Sorry, Jessica, we'll come.
Yeah, I was interested in the different personalities you found in the Earth. And do you know kind of what the relative contribution is of each personality in the wild? And how that could contribute to the overall survival of the population? And how that could maybe change if, for example, cockle density suddenly drop? How do they differently respond?
Yeah, so the question is, what is the distribution of these exploration behaviors, these exploration personalities across the population of red knots? And how can external environmental factors influence their survival and this distribution of exploration behavior, or these personalities? So the distribution, it's a continuous, it's sort of a normally distributed relationship. So there's many individuals that are averagely explorative, and then there's some extreme ones. So it's not bimodal in that sense, that you have two groups. And we didn't find any relationship with survival in this data set of over 4 years of catching and then 10 years of resighting. So but I also think it's a very interesting idea. With different species, you do find that in poor environmental conditions, certain personalities do better than in other environmental conditions, and then you get fluctuating selection towards one or the other. But I don't think that's happening with red knots. We don't have evidence for that, at least. It's just different strategies that amount to the same survival, regardless of the changing environment.
Okay, Bert, is it nog, you're still burning.
A question, one of the first slides you showed on the searching behavior.
Yeah.
And you said we have one bird and it takes longer to find a prey than when you have 2, 3 or 4 birds searching. But yet illustrated by this box plot.
Yeah.
And I wonder how sound that conclusion is statistically. Because I see a large spread of data, and you draw a line, but when I leave out the first one, then it's more or less a horizontal line. And
shall I get the graph?
Oh, shit.
You have it already?
yeah, that one.
Yeah. So
It's well, there is a difference, and
Yeah,
on the log scale, of course, but the difference is not very clear, I think.
Yeah, but when you calculate this in how efficient they are in searching for prey, then it's what was it again? That was how fast they find their prey is proportional to group size. Actually, yeah. So that effect is quite substantial, I'd say. Because the slope doesn't deviate from -1. So it is a substantial effect. But I understand what you're saying here, that it's you could argue that, but you can also argue in the top plot if you leave out that second group that it becomes stronger.
And maybe you should not put it on the log scale. Maybe you should not put it on the log scale.
Yeah, maybe. Okay, I just heard here's some calling again, so no, I don't know. Daphne, although you're a small sample size, do you have a question?
High quality question.
Yeah, high quality question.
We do not have questions, so...
Oh. Crystal clear.
Great talk. Unanimously.
All right. If there are no more questions in this audience, Thomas.
Allert wanted a question from me, so it follows up a bit on the question from Anouk, so it is really a complete layman's question. You experimentally demonstrated that jitter size can change, but somehow, if I'm not mistaken, you assume that exploratory behavior is constant per individual.
Yeah.
Could it also be that, you have the sedentary birds, which I will call the lazy bird. You have the exploratory bird, which I will call the ADHD bird. Could it be that the lazy bird will remain lazy even if it means starving to death? And will the ADHD bird will remain moving all over the place even if it finds one nice spot where we can have breakfast and lunch and dinner and another breakfast and so on and on and so on? Or could these personalities also change for any given individual?
So so that's a good summary of your question. Could these personalities change within individuals.
Yeah.
Sorry?
Yeah, they don't listen.
I don't
No need to repeat.
It's easier. Right. So of course it's not a fixed percentage of time. It's not completely fixed. There's variation within individuals in how explorative they will be or will not be. So in that sense, they have this flexibility. But what I always found striking with certain experiments that we did with foraging, we often starve them for 1 or 2 hours before we do these experiments to make them motivated to find food. And then some of these birds just never did anything. So there's one bird that I have to think of that declined in body mass also during the period, just didn't want to cooperate with us. And, so in that sense, it's very stubborn or fixed. But
in nature, that one might start there.
Yeah, it might. Yeah, but in nature, it's also a social species. So we have measured these personalities of individuals, but in the groups, they also have dynamics of each other. So maybe they're in a flock. There's some explorative individuals that go to new patches, and the other ones just follow. And in that sense, they also arrive where they have food.
Oh, okay, so if one bird is naturally lazy, needs someone else to say, hey, come
Perhaps,
on.
yeah. So as a cliffhanger also, I haven't analyzed these data yet, but we did a follow-up experiment with Thomas Lering, and where we combined an explorative individual in this setup of this actually. So in this setup, we buried natural prey densities, and in this setup we paired an explorative individual with an unexplorative or sedentary individual to see, and we can calculate based on this food density, calculate exactly how explorative it should be. And these explorative individuals by themselves are too explorative, they leave too fast, they should stay a bit longer in a patch and search for the remaining food. Whereas these sedentary birds, they stay way too long and they should go to another patch where there's more food. And then our idea was if we pair them, maybe we optimize these giving up decisions as a flock.
Yeah.
So, but that's, it's a cliffhanger, maybe the next talk. I haven't analyzed it.
All right, great. That's the end. And hands clapping again.